Have you ever pondered over the crucial role of railway tracks in our transportation system? These seemingly simple structures of iron and steel are an intricate piece of engineering brilliance that serve as the backbone of our locomotive journeys. When we think of railway tracks, the image that often comes to mind is a pair of parallel lines stretching out into the horizon. But there's so much more to these tracks than meets the eye. They're not just slabs of metal laid on the ground, but a complex system that's been engineered with precision, serving as the veins of our global transportation network. Every inch of the railway track, from the rails to the sleepers and the ballast beneath, is a testament to human ingenuity. It's a marvel of engineering that's been refined over centuries, constantly evolving with the advancements in technology and material science. The railway track is the stage where the play of speed, weight, and safety unfolds. It has to withstand the immense weight of the train, the high speeds at which it travels, and the varying weather conditions it's exposed to. The track must ensure the smooth and safe passage of trains, day in and day out, without fail. What's more, the design and layout of these tracks play a critical role in determining the efficiency and speed of travel. The curves, the gradients, the distance between tracks. All of these factors are meticulously calculated and implemented to create an optimal transportation system. So the next time you find yourself gazing out of a train window, take a moment to appreciate the marvel beneath you, the railway track. It's not just a path for trains to travel on, but a symbol of human progress, connecting cities, countries, and even continents. And this is just the beginning. There's a whole universe of fascinating facts and figures that make up the intriguing world of railway tracks. If you're curious to know more about what goes into creating the ideal railway track, you're in the right place. Stay tuned as we delve deeper into the fascinating world of railway tracks. The making of the perfect railway track is an art and a science, governed by a set of key requirements. Just as a painter requires a canvas, the creation of an ideal railway track begins with the selection of the right gauge width. It's the distance between the inner sides of the rails, and it's at the heart of railway track design. From narrow gauge to standard gauge and even broad gauge, the choice of width directly impacts the stability and speed of the train, serving as the foundation of a safe and efficient railway system. Now, let's consider the track material. From the early days of wooden rails to the modern-day use of high-quality steel, the choice of material has evolved drastically. Steel rails, with their high durability and ability to withstand heavy loads, have become the industry standard. They provide the robustness necessary for trains to cruise at high speeds, yet are flexible enough to absorb the constant pressure of the moving trains. And what lies beneath these steel rails? It's the track bed, a layer of crushed stones or ballast that plays a crucial role in distributing the weight of the trains and maintaining the stability of the track. But it doesn't stop there. The ballast also aids in drainage, preventing water from pooling around the track, which could otherwise lead to potential safety hazards. Lastly, we have track alignment. Imagine you're on a train and suddenly you feel a jolt. That's a sign of improper track alignment. Correct alignment ensures a smooth and comfortable ride for passengers and freight alike. It helps to prevent derailments and other dangerous situations, contributing to the overall safety of railway operations. So, from gauge width to track material, bed composition, and alignment, each aspect is a crucial cog in the wheel of an ideal railway track. Just as an artist meticulously crafts every detail of their masterpiece, engineers too must carefully consider each of these elements in their design. Now that we have an understanding of the basic requirements, let's explore them in detail. The gauge width, a seemingly simple dimension, has profound implications for the operation of a railway system. To dissect this further, let's imagine the gauge width as the distance between the two rails of a track. Now, this width plays a crucial role in determining the stability, speed, and load capacity of the trains. It's like the foundation of a house. If it's not right, everything built on top of it would be shaky at best. To give you an idea, a wider gauge provides a greater stability, especially for higher speeds and heavy loads. It's due to the increased lateral balance the wider base offers. Picture yourself standing with your feet apart versus standing with your feet together. You can undoubtedly balance better with a wider stance, right? Similarly, wider gauges offer better balance to trains, especially when they're cruising at high speeds or carrying heavy loads. On the flip side, Wider gauges mean more materials, more land, and hence more expenses. It's a delicate balance that railway engineers have to strike. Now you might ask, what's the standard gauge width? Well, the widely accepted standard gauge is 4 feet 8.5 inches. Yes, it's oddly specific, isn't it? But there's a reason for this precision. This particular gauge width is the sweet spot that balances the need for speed and stability with the practicality of construction and maintenance costs. It's the Goldilocks of gauge widths, if you will. And it's not just about the here and now. The decision of gauge width has far-reaching implications. If a country decides to change its gauge width, it can't just switch overnight. It would require revamping the entire railway infrastructure, a colossal task both in terms of time and money. So, the next time you're on a train, spare a thought for the humble gauge width. It might seem like a simple distance between two rails, but it's a carefully calculated decision that affects everything from the train's speed to its stability and even the cost of your ticket. Any deviation from the standard gauge can have significant ramifications. The material used for tracks and the composition of the track bed are equally important. We're about to delve into the nitty-gritty of what makes a railway track robust and reliable. It all starts with the choice of materials. High-quality steel is the go-to choice for the tracks themselves. Not just any steel, mind you. The steel used for railway tracks is a specific kind known as carbon manganese steel. This type of steel is strong, ductile, and resilient to the considerable forces exerted by trains. What makes carbon manganese steel so special? Its ability to withstand the wear and tear of heavy loads without deforming or cracking. This is a crucial quality, as deformation can lead to derailment, and nobody wants that. Additionally, this steel is less prone to corrosion, which is a significant advantage in regions with high humidity or coastal areas. Now, let's shift our focus to what lies beneath the tracks, the track bed. This is not just a pile of dirt scooped up from the nearest field. It's a carefully composed layer of crushed stones or gravel, known as ballast. The ballast serves multiple purposes. It distributes the load from the tracks, provides drainage, and helps to reduce vegetation that might interfere with the track structure. The crushed stones are purposely sharp and angular, not smooth and round. This is to ensure they interlock with each other, providing a stable base that can withstand the dynamic loads of passing trains. The size and type of stone used in the ballast can vary based on several factors, including the type of traffic and the load the track is designed to handle. So, as we can see, the durability and stability of a railway track are not just about laying down some steel on the ground. It considers the quality of the steel, the composition of the track bed, and even the shape of the stones in the ballast. Choosing the right materials is crucial for the safety and longevity of railway tracks. Last but not least, proper track alignment and maintenance are key to the smooth operation of trains. When we talk about track alignment, we're referring to the geometry of the railway track. This includes its horizontal alignment, vertical alignment, and cross-level. Proper alignment is critical because it directly impacts the safety and efficiency of train operations. If the track alignment is off, it can lead to a number of issues, including uneven wear on the rails, increased fuel consumption, and in the worst-case scenario, derailments. Think about it like this. If a train is a giant metal snake, then the track is its path. If the path isn't smooth or straight, the snake might have a hard time slithering along. In the same way, a train needs a well-aligned track to move smoothly and efficiently. But track alignment isn't a one-time deal. It's not something that's done once when the track is first laid down and then forgotten. Far from it. Tracks are subjected to a lot of stress and strain, from the weight of the trains to the impact of the weather. Over time, these factors can cause the alignment to shift, which is why regular maintenance is so crucial. Maintenance involves checking the alignment and making any necessary adjustments. It also includes inspecting the track for any signs of wear or damage, like cracks or breaks in the rails. But it's not just about fixing problems. Maintenance also involves preventive measures like lubricating the rails to reduce friction and wear. And let's not forget about the track bed, the foundation on which the track sits. Maintenance also involves ensuring that the track bed is stable and free from any issues like subsidence or washouts. In essence, maintenance is all about making sure that the track is in the best possible condition so that trains can operate safely and efficiently. It's about being proactive and catching potential problems before they become actual ones. Regular maintenance ensures that the railway track continues to meet its requirements and serve its purpose effectively. So, what makes an ideal railway track? We've covered a lot of ground today, from the blueprint of the perfect track to the nitty-gritty of its construction and upkeep. Let's circle back to the key elements. Gauge width, for example, is not just about size, but the careful calibration to ensure smooth and safe journeys. Then we have the track material. It's not just any metal, but a well-researched alloy that balances strength and flexibility. We also dug into the bed composition, a blend of rocks and materials that form the track's foundation, providing stability and drainage. And who can forget alignment? It's a meticulous process that ensures the tracks are laid correctly, reducing wear and tear and promoting longevity. Finally, maintenance, the unsung hero of railway tracks. It's an ongoing commitment to safety, efficiency, and durability. Remember, the next time you see a railway track, there's more to it than meets the eye. It's a marvel of engineering designed for precision, safety, and efficiency.